So here we go with the fourth video for lesson B as in boy in Algebra 2. And looking at the top of page 15, we've got the base of a right cylinder that's 10 feet high, and they want us to find the surface area of the solid. So they've given us an object that looks like this, and it kind of comes around like that, and that comes down, and that comes down. So I need to know how much paper, metal, whatever it's going to take in order to make that object. So I have to find the area of the top and the area of the bottom, which is going to be the same thing. So it's going to be two of these added together, and the area of this, and then the area of this as it goes around the back. So there's a picture at the top of page 15 from the top, and so I'm going to go ahead and draw that. And that's telling me this is 6, this is 5, and from here to here is going to be 3. So this 5 only goes to right there. So I'm going to find the area of this by finding the area of the rectangle and then the area of the half circle, add those together, and that will give me the area of one of the bases, and then I double it and I will get the area of both of the bases. In this case it's 44.13 for one of the bases, so the other one is also going to be 44.13. And the next part I have to come up with is called the lateral surface area, which is the up and down surface area. So when I'm looking at the lateral surface area, I'm looking for the area of, well, let's look at the three-dimensional, the area of that and the area of that all the way around to the other side. So it's going to be this length here all the way around, so the perimeter of that whole thing times the height, which in the book it says that height is 10. So I'm going to find the perimeter, what I have here in blue. I'll multiply it by 10, and that'll give me the surface, the lateral surface area, the up and down area, what I have here in blue. So what I'm going to do is I'm going to unfold this whole thing. So if I unfold it, I'm going to get a rectangle, and the height of that rectangle is going to be 10. And if I go from here to here, that is 6. So let's say that this part right here is that back there. And then I am going to look at what I have here, this length from here to here. Well, when I look over here at my flat part here, this is 5. So let's go ahead and put a 5 here. And then from here around to here is a half of circle. So the circumference of the whole circle would be 2 pi r, which would be 2 times 3.14 times radius is 3. And I want half of that, so I'm just going to take half of that. So when I take half of that, I'm going to cancel that and cancel that. And I have looks like 9.42. And that would be the circumference from here around to there. And now I have this here, this 5 here to put on there. Alright, so I've got the length from there to there, which is going to be all 4 of those numbers added up, times 10. And that would give me the lateral surface area, which is 254.2. That's the lateral surface area, and I add it to these two, the area of the base and the area of the height, and I have the whole surface area of that solid. Just a couple more formulas to put in your notes. If we're going to look at the surface area, and I'll just abbreviate, of a sphere, surface area of a sphere is 4 pi r squared. And when you're doing lateral surface areas of cones in the middle of page number 16, it gives you some methods in order to do that, having to do with slant height. And the slant height, if you look at something, I'll just kind of make a real bad drawing of one of these pyramids. The slant height would actually be how long it is along the slant here. So that slant here or this slant here, that would be the slant height. And sectors of circles, which is the last part of this section. And we've got a circle. And a part of the circle is called an arc. So if we're only looking at this particular part of the circle, this is called an arc of the circle. So any part that we pull out of there. If we draw from the center point a line to one end point of the arc and a line from another end point of the arc, so if we draw a radius connecting the endpoints of the arc, we get a piece of the circle, an area of the circle, a piece of pi it looks like, and that's called a sector. Alright, so one of the things I want you to notice is the degree of the arc is the same as the degree measure of the central angle. So if this angle right here was 20, then the degree of the arc is also 20, as long as the vertex of this angle here is at the center point. And that's called a central angle, is if the vertex is at the center of the circle. So that is a true statement. This is 20 and this is 20 if and only if the vertex is at the center point of the circle. Now, if we want to find the area of that circle, or of that sector, that piece of pi, we know that in an entire circle we have 360 degrees. Well, if we're only talking 20 degrees of that circle, then we're looking at a fraction of the whole circle, 20 out of the 360 degrees. And if we then multiply that fraction of that entire circle by the area of the whole circle, which is pi r squared, we will be able to find out the area of that sector, that piece of pi that I have there. So again, notice what we've got here. We're saying we've got the area of the whole circle, and that's the area of the circle, times the part that we're looking at. We're only looking at 20 out of the 360 degrees. So we multiply the whole area of the circle times the part we're looking at. And this will always be over 360 degrees. So whatever angle this is over 360 degrees is the part of the circle that we're looking at for this particular one. So one final thing I would like to note in here is if you ever want to find the length of this arc right here, all you do to do that is to take the degree right here, 20, over 360, and it's always over 360, times the circumference of the whole circle. So in this case it would be 2 pi r, and let's just say that our radius is 6. So this length from here to here, let's just say that it's 6. And that would give us the length of the arc. So 20 over 360 is 0.056. We're going to multiply it by 12 pi, and 12 pi is 37.68, and we're going to multiply that by 0.056, and that gives us a length of 2.11. That right there is how long that is.